is just the sum of a sequence. That's what a series is. It's the sum of the terms of a sequence. So we're just taking sequences, adding a little step to that. And so if we've got A1, A2, A3, so forth, we're just going to be adding the terms up of that sequence. So we're going to add A1 to A2 to A3 to A4, so forth and so on, and it's going to be infinite. So, of course, we can write that using our summation. And so that'd be the sum of the a sub n's. N is starting at 1, going to infinity. So we're just talking about the sum of the sequence. Now, because we are talking about infinite series, the notation here sometimes we'll just shorten it to say that. Okay, it's the sum of the a sub n's. In other words, if you see that, then implied here is n equals 1 to infinity. Now, sometimes it may not start at n equals 1, may start at n equals 0, may start at n equals 2. So if that changes, they'll denote that. But if we just see that, that's what that means. So, for example, what would this series be? Sum of the 1 over n squareds. Well, it would be 1 over 1 squared, 1 over 2 squared, 1 over 3 squared, 1 over 4 squared, plus dot 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 1 over n squared, plus, though it goes out infinitely. So it doesn't stop at anywhere. It just keeps going and going like the Energizer Bunny there. Okay? Doesn't ever stop. Now, what we'll be interested in is finding, if we can, what this actually equals. Because a lot of these that we'll talk about, they do converge. The series, not just the sequence, but the sums. If you add up all these terms together, the sums will all converge to a number. Not just, I mean, obviously, this is the sequence is going to 0, but the sum's not going to 0, but it may very well be going to a number for the entire infinite series. That's what we'll be looking at. Now, there are some obvious ones, like the sum of the n's. That's definitely not going to converge to a number, because that would be 1 plus 2 plus 3. Is that ever going to equal a number? No. That's just going to keep growing larger and larger and larger. So that one's not one of interest to us, I mean, other than to say that diverges. It won't ever converge to a particular number. So that's what really the rest of this that we're talking about is all about, is coming up with the sums, or seeing if the sums of these series actually converge to a number. We'll do that different ways. The first way they start us looking at it is with what are called partial sums. Partial sums. If, say I'm talking about the series a sub n, the nth partial sum is just like the name suggests there. It's the sum of the terms up to the nth term. All right, so if I'm talking let's just start with kind of the small here, this second partial sum for this series would be, well, it would be the sum of the series up to the second term. So that would be, and it's denoted S sub n. So this would be S sub 2 equals, what would the second partial sum be? Well, it would be the sum up to the second term. So it would be A1 plus A2, right? The fifth partial sum would be S sub 5. Well, that would be all the terms up to the fifth term. Okay? So that's the terminology, partial sum. It's just adding up a few of the terms or the terms up to a certain point. Okay? All right, now, it is noteworthy here, I guess. We could say that the nth partial sum, we could write that in our summation notation as this. The S sub n is going to be the A sub i's with I running 1 to n. Little different symbols there, but that's what we do. Okay? All right. So let's do sum for a particular one. Okay? Write out the first 5 terms, first 5 partial sums for the series sum of 1 over 2 to the, times the n plus 1 denominator. I'll write out the first 5 partial sums. S1, S2, S3, S4, S5. Okay, so what is S1? S1 is just the partial sum that is just the first term. So S1 would be 1 over 2 times 1 plus 1. So that'd be just 1/4. S sub 2, though, that would be the first term plus the second term. So that would be this term, the 1 over 2 times 1 plus 1, plus 1 over 2 times 2 plus 1, right? With me? Just do the first 2 terms. So that's 1/4 plus, what, 1/6? S sub 3, then, would be the first 3 terms, A1, A2, A3. So I'm just going to plug in n equals 1, n equals 2, and n equals 3. So that's just going to get me same thing, except I'm going to add one more term. 1 over 2 times 3 plus 1. So the idea is each time we're just adding an extra term, right? So that would be what? 1/4, 1/6, 1/8. I think I see a pattern there, don't you? So what would S4 be? Well, S4 would be the first 4. So it would be 1/4, 1/6, 1/8, and then 4 would be 1/10, wouldn't it? And then S5 would be 1/4, 1/6, 1/8, 1/10. And then the fifth one would be plug in 5, so it would be 1/12. Okay? All right. Well, the idea here then is let's look at, can we tell if the partial sums, if we can tell anything about the entire series from the first few partial sums. So let's do that with this next one. Give us a little practice on some more, but here's another one. All right, let's write the first 6 partial sums. Okay, S1, S2 through S6. And notice a couple things. All right, S1 would be the first one, so that'd be 7/4. S2 would take the 7/4 plus what? 7/16. So what is 7/4 plus 7/16? Well, that would be 35/16. 35/16. S3 would be 7/4 plus 7/16 plus 7/64. Which is, fraction-wise, 147/64. Now, what we might note there is for S4, yeah, it's 7/4 plus 7/16 plus 7/64 plus 7/256. What we might note there is S4 actually, what are the first three terms? First three terms are S3. So I'm just adding to S3 one term, so you don't have to do the whole thing over again, right? You just have to add to the 147/64, add 7/256. That's how we're getting these. Whoops. Turn that over 595/256. That's S4. So S5, well, S5 would be, you know what it is, but it would be S4 plus the other term would be 7/4 to the 5th. I think that's 1024, right? Which is, let's see if we'll do it, 2,387/1024. And then S6 is will be S5 plus 7/4 to the 6th. So let's see if it likes, oh shoot, 2387, let me do that again, plus 7/4 to the 6th. Oh, no. 387. Okay, I didn't have it right anyway. Well, yeah. All right, that would be okay. All right. Okay. There you go. All right, well, seemingly there, I don't know. Is it going anywhere? Very careful. Yeah. And, you know, sometimes you might be able to tell what's going on here. Yeah, this one's 2.3327. I can't remember what that one was. 2.33. Yeah. So it looks like it's hovering around the 2.33 mark there. So anyway, we can make a little hypothetical guess at that, but maybe not. Now, one other one. Let's do the same thing with this one. Okay, first 6 partial sums. Of sum n equals 2 infinity minus 1. Now, here's the thing on this one. Notice the index is different. What's it different about this index? This index we're starting at 2. Why would we want to start at 2 instead of 1? That's because of the denominator, right? sometimes you have to make adjustments because of your denominator. If I start at 1, I'm in trouble right off the bat because I don't have a value at 1, do I? It's undefined. So I don't want that. That'd be too easy of an answer. No answer. No, this one. So watch out for the index here. All right, so S1 though would still be the first term, which would be 2 minus 1, 1 over 2 minus 1, which would be 1. S2 is 1 over the 1 plus the second term would be 1/2. That's 3/2. S3 then would be the S2 plus the third term would be n equals 4, so it would be 1/3. 15/6, I don't know. 11/6, which is 11/6. S4, then we take the S3 and add to it the fourth term, which would be n equals 5, actually, so that would be 1/4. So yeah, we're just adding the next term there, which turns out to be 25/12. S5, S4 plus the 1/5, which is 137/60. And S6 is S5 plus 1/6, which is 49/20. No. Yeah, 49/20. That's what I get anyway. Let me make sure on that one. Okay, so S 25/12 plus the 1/5. And then 60 plus the 1/6. 49/20. Okay, we're good. All right. So yeah, it's still, even with that, you wind up with some harder calls there. Let's see, 11. This one's 245. This is 2283. 20833. 1833. Yeah, so it's a little tougher to call on that one, isn't it? Because it doesn't seem like these numbers are leveling off anywhere, does it? So that might be a hint. We'll look more at it in a second, though. So yeah, so the next step then is to say, well, do these sums, do they actually level off? Do they converge to a particular number?